Welcome to Techtastic, where we navigate the intersection of technology and business, uncovering innovations that redefine our world.
Bryan DeBois joins us today on It's Techtastic, and he's got a long background in industrial AI. And this is a space that I personally find very, very interesting. So I want to say, Bryan DeBois, welcome to It's Techtastic. It is lovely to have you here.
Thanks, Christian. Yeah, awesome to be here.
So there's a couple topics that I think that are very interesting that are related. One, industrial AI and advanced manufacturing, I would assume, means like 3D printing, CNC, robotic assembly, that type of thing. You're probably an expert there.
Yes, somewhat. And it's interesting because, to be an expert in all those things you just listed is tough to find one person.
Right.
There's definitely aspects of that we do. We do some CNC, we do some robotics. Actually, in a lot of ways, that industrial AI that we're going to be talking about is actually applied in the more traditional automation spaces of the manufacturing facility. So I don't know how familiar you are, but if you think of PLCs and some of these more traditional automation that's been around for a long time, we can actually apply
Bryan
that industrial
DeBois,
AI on top of those existing control
systems.
systems.
To have you here. Ooh, now, so there's a big need there.
Yeah, CNC is very specific. It's actually kind of a specific niche within the broader manufacturing world. And we do, like I said, we do some of that, but really if you focus more on manufacturing lines as a whole. So if you've ever seen the show How It's Made, that's typically what I refer people to, right? So I watched that growing up, loved it, really knew nothing about the manufacturing space before I moved into this 24 years ago, started at my current company, Rovisys, 24 years ago, and learned everything, about this manufacturing space. So while robotics certainly plays a role in certain industries, in other industries, it's piping, it's big reactors. If you're making chemicals, if you're making life science ingredients, pharmaceutical ingredients, if you're making food and beverage type products, there's less robotics there and there's more just conveyance, and you've got big, again, reactors and vats of things and piping, material around and things like that. We can actually apply industrial AI to solve that. And by the way, the same labor shortages that they're seeing on the CNC side that you referred to, we are absolutely seeing that across the board in manufacturing.
So I have a particular passion for advanced manufacturing. I actually have a patent out there from a very long time ago in the space. I don't think I've ever shared this on the podcast, but the year between high school and university, I went and worked for a high-tech fab on the graveyard shift in their prototyping lab for what would become the phase change printers for Xerox, but at the time it was Tektronix.
Okay.
Acquired that division. And that gave me a whole bunch of insight into how that type of printing was done. And I started applying that to 3D printing and all that kind of fun stuff.
Mm-hmm.
Now, you're not exclusively talking about 3D printing, but I have a fascination with it because a different problem that we've tried to solve repeatedly can be addressed with it. And that problem is this, and I don't know that we'll spend a whole lot of time talking about it, but as the world moved from solely information being online to basically all physical goods being available online, there was a transition phase that went through, but there was a forcing issue that was becoming a reality for anybody in direct to consumer. And that was, I want it now.
Yeah.
Right?
Yeah.
But I think it's gone beyond that. I think I want custom and now. You can solve the I want it now with logistics, with very intelligent AI-driven logistics, but you can't solve the custom problem.
Right. So it sounds like that was probably quite a few years ago.
It was.
And additive manufacturing has advanced significantly since then. And and I'm not an additive manufacturing expert, but I do monitor these trends. And one of the areas in particular that we're seeing huge improvements there is not even the direct to consumer route, but think being able to 3D print major components of airplane wings. And so in the past, you only had limited options, right? You could CNC these parts, you could cast them, or you could forge them. I mean, those were basically your options, and all of them have pros and cons, particularly in really complex parts. And so what ends up happening is you end up having to break a large complex part into several smaller parts. Each of those then has different failure points between them in the connecting all of that back together. With additive manufacturing, they can actually print that all as one single piece. And so there's a lot of research going into that. We actually worked with a company that was experimenting with making the metal powder that would eventually be used in these big additive manufacturing facilities. And by the way, that metal powder is really dangerous because it can explode.
Yeah.
And so that was a very interesting project to work on. But that's not my area of expertise, but I think there's a lot of really interesting things that are going to be coming down the pipe for additive manufacturing.
The additive manufacturing part, like I said, is a bit of a passion space, and I spent a lot of time screwing around with it, but as a hobby more than as a career, right? I went hardcore down the software side of the world into AI. So the industrial manufacturing, applying AI to, I'm assuming, processes to help do improvements and efficiency gains and all that kind of fun stuff. I really wish that one of my former colleagues who worked with a couple different companies was here, Diana. She did process improvement for some very large companies around their manufacturing process, because she's a process engineer. And she would be the best guest to pair you up with on this, to ping back and forth.
Yeah.
I want to hear more about it. I want to understand it better, because when we were talking at Wayfair around a couple different problems, one of them was the custom and now, and in furniture and home goods, that's a really hard problem to solve, because it's hard enough to get enough sofas in the door to be able to have a big catalog. It's a whole nother thing to be able to have an advanced manufacturing facility that can do all the possible things that are involved in furniture. But to even get to that step, you first start refining the process. And with Nike, with the ID product, the custom shoe you could design online, that was fully figuring out the process across many different facilities to try to do it backwards. What can we offer the consumer? And when they start making selections, how do we limit them to only the things that that facility can manage?
Right. When you talk about process improvement, this is very much in Lean and Six Sigma and these existing process improvement methodologies that have been around for a long time. Industrial AI is another tool in that toolbox. So we try to say to our customers, this isn't the silver bullet. It's not going to solve all your problems by any means. However, what I've seen is that we can apply some of these more advanced industrial AI techniques, which I can talk about here in a minute. We can apply them to problems that have typically been unsolvable in the past. And what I mean by unsolvable is that you typically would just have to throw manpower at a particular problem, or it was just a problem that everyone just kind of lived with, and it was kind of the state of the art of that manufacturing, making that particular type of product, and nobody really knew how to solve that. You know what I mean? So it was just... Yeah. That was just how you did things. And we're now able to attack those types of things. And one of the advanced types of industrial AI that Rovisys actually specializes in, and this is cutting edge stuff, it's called autonomous AI. So this is where we're actually able to train AI models to make human-like decision-making on the plant floor. And that is where we've been able to solve these unsolvable problems. That's where we've been able, from a process improvement standpoint, been able to squeeze out, single-digit % improvements that equate to millions of dollars every year on lines that maybe have already been optimized and they've gone through Six Sigma. And it's there's nothing more you can do to this line until a technology like this comes along, and now suddenly we can make improvements that have never been able to be made before. One of the other interesting aspects of this is that there's also kind of a flow through to sustainability, right? Because if we can reduce scrap or we can reduce energy consumption, yes, the company makes more money, but it also has a direct impact on landfills, and it has a direct impact on wasting materials, and it has a direct impact on wasting energy. All of that then flows through from a sustainability standpoint, which is a big win, because a lot of these companies now do have sustainability goals too. I mean, when they look at trying to hit some of these aggressive sustainability goals, even with all of the existing process improvement methodologies that are out there, you're not going to get 1 to 2% improvement on energy reduction and things like that, unless you look at an advanced technology like industrial AI. So that autonomous AI that we're talking about, the underlying technology behind it is a technology called deep reinforcement learning. Now, you're very plugged into this world. Is that something you're familiar with?
Yes, I am, but you should explain it to the audience.
Yeah, for your audience. So deep reinforcement learning came out of DeepMind, which was a Google spinoff, and around 2016-ish, they had a program come out called AlphaGo. It beat our best Go grandmasters. They did the same thing with AlphaZero, which beat our best chess grandmasters. Then they did the same thing with AlphaStar, and it beat our best StarCraft players. So they were onto something. And some very clever people said, well, okay, we can take this technology that's kind of, right now it's being used to play games, and we can actually apply it to the industrial world. So now fast forward, almost a decade later, and we now have customers that are leveraging this deep reinforcement learning technology to make human-like strategic decisions, which is really that strategy aspect is one of the key things that sets DRL apart from other AI approaches. Be able to make those human-like strategic decisions on the plant floor, and that we're able to apply that. And I love this about it. We're able to apply autonomous AI to solve problems as varied as actually controlling the control system. So actually making the product and turning the knobs just like an operator on the line would to make better product, more on-spec product, all the way to production scheduling, which is a notoriously hard problem. And again, when you talk about trying to get to this made to order, made to custom type of world, specific and specialized customization, production scheduling becomes one of the biggest bottlenecks to that. And we can actually apply this to solve those types of problems as well.
One of the other things that just keeps popping into my head is the non-uniformity of manufacturing. Any two lines doing the same thing for the same company can do it fundamentally differently because of past equipment purchases or whatever.
Yep.
So do you have to do domain reinforced learning model per line type situation? Or is it like you're deploying one and it kind of understands the differences?
So it just depends on how close the lines are. But in a lot of ways, once we get a working simulator, we can oftentimes just do some quick modifications to the simulation to get it working for the second line. And then we've got, all of the pipeline in place and all the project in place to be able to retrain that brain on the second line. So it depends. Some of our customers are at least within lines within the same facility. They've been really good over the years at keeping all of the equipment the same, and because they also have to maintain these lines. So they have had incentives over the years to try to keep stuff as standardized as possible. And obviously they now reap the benefits of that if they were able to do that, because now we can train once and deploy at multiple places. But certainly between facilities, we absolutely see that non-standardization that you're referring to. So it depends, but we typically can get a good amount of reuse. There's another aspect though that really makes this reusable that's worth emphasizing, and that's that this autonomous AI approach isn't just about DRL. That's why I don't just refer to it as DRL. There's another really important aspect, and that's what's called machine teaching. And machine teaching is where we actually sit down with the subject matter experts. We extract from them their expertise, and we actually bake it into the model. So we actually build a workflow that represents their heuristics. Some of them, maybe not even be written down. It's just like, oh yeah, when I see this RPM kind of going this way and I see this, that I know I'm in this state, so I'm going to do this. Versus if I see this RPM going low and I see these other things happening, I'm in this state, I know I'm in this state, I'm going to do this. We build a workflow of all those decisions, and then we actually hand that to the DRL, and it actually trains around that. It's still able to find all kinds of insights that a human wouldn't have thought of, but that actually guides its training. And the nice thing about that is that's almost always reusable across lines, regardless of the underlying equipment and things like that.
I was going to say that part alone is really, really valuable.
Oh yeah.
Because you can have same role, same line, same function, different shift, and they're doing things just a little bit different because they haven't picked up that specific piece of knowledge that they need.
Right.
So the variability that you're going to have because there's humans involved in operating this. But then I wonder though, like the way that you get information out of people itself ends up being a particular problem, because I can imagine a simulation that they're involved in, right? And as they're responding to the simulation, they're basically training your model. But a question and answer thing, like you have to know what questions to ask.
Oh yeah. It helps that we've been at this for a long time. So we have a lot of expertise, deep expertise here at Rovisys across all the different industries we work in, and we work across 14 different industries. So if we're going into a life science customer, we know generally the process, and we know enough that we can sit down with an expert operator. And so we know generally we could write that workflow ourselves without probably having that interview. But what we're trying to get out of the interview is let's get real specific about this part of the process, and what are the heuristics and what are the tips and tricks that you use to squeeze the absolute most out of this part of the process. And that's really then what we want to give as kind of a starting point to the autonomous AI, so that while it's training, it at least knows what are the best practices. As you pointed out, though, that's a really interesting aspect of all of this, because that is what a lot of our customers are interested in, because those experts are retiring. So as an example, I have a vinyl extrusion customer, and I was visiting and I was talking to the plant manager, and he said, I've got two guys who are absolute experts at running this vinyl extrusion line. And he goes, both of them are 5 years from retirement. He said, I don't have a bench. He said, I've got 1 and 2 year guys. I've got high turnover in that position. Nobody really wants to spend the next decade of their life learning how to run a vinyl extrusion line. And that's just kind of the way it is right now. And we can lament that, and we can wish that it was different, or we can just embrace the fact that that's the situation right now, is that nobody wants to spend the next 10 years learning how to run these lines. And so that expertise is in the heads of those two guys. And he knows that as soon as they leave, his options are either adopt AI or live with the fact that the line's never going to run as well as it did, with those experts. So this gives, those folks an opportunity to extract that expertise from those SMEs and bake it into these AI systems. Now this thing can look over the shoulder of a first year operator and say, hey, if you just turn this knob 2% more to the right, you're going to squeeze this much more operation out of the machine. And what's interesting is, in talking to those SMEs, a lot of people would think that they would feel threatened by that. It's the exact opposite. These folks have spent their life learning how to run this equipment. This has been their passion project, their career. And this is what they see as their legacy, right? Is baking all of that expertise in. It's funny, I gave this example once. I said, if I'm one of those guys who's an expert at running a vinyl extrusion line, and I've spent the last 15 years of my life learning how to squeeze every little bit of performance out of that piece of equipment. And vinyl extrusion, it's a large, complex process, big equipment. And I know everything there is to know about that. Who am I going to talk to about that? Right? My buddies at the bar don't want to hear a word about it. And I can guarantee you my wife doesn't want to hear anything about it when I get home. Yeah. And yet I sit down, me and my team sit down with this expert with humility, and we say, tell us everything you know about how to squeeze how do you do it? How do you do it so well? They light up, like they're so excited to talk about this. No one's ever cared before. And so we're able to extract all that, bake this into the AI, and then be able to build a human-like decision-making neural network that can then sit on the line and be able to advise the next generation of operators on how best to operate that line.
I can think of a couple things that would make me a little bit nervous about technology like this. My company does AI also, and we're solving weirdly kind of a similar problem, but in a totally different place in software development. And one of the things that concerns me about it is that it's like dumbing down of the people that are doing the role, and how we're taking away the parts that we think of as innately human, and we're giving that to the machine. And now the human is doing the parts that seem almost like the machine part, like turning the knobs because a different brain told me. What worries do you have about what you're doing, or do you have any concerns about the future based on where we're going?
Well, I'm kind of a natural worrier anyway, so I have lots of worries. But I would say that, so it's a general worry that I have anyway about anywhere from autonomous driving to autopilot in planes. So the more capable that we make a plane of being able to fly itself, the less muscle memory we're building in our pilots to be able to handle those weird one-off 1% of the time emergencies that can happen. And as we saw, there was that Air France, I think it was, plane that crashed in the mid-2000s. And it was a fully functional plane. Literally nothing went wrong. And what happened was the transition from autopilot to a human pilot. And it was a less experienced pilot. The experienced pilot had actually went to sleep and turned it over to a less experienced pilot. And it's like, just fly the plane. Like, you just have to fly the plane. Keep it straight. And they had one of their tubes froze, and very natural thing happens all the time. The autopilot switched over to manual. And that transition from auto to manual, it's the same thing in autonomous cars. That transition from auto to manual is a very concerning area for me, especially moving forward. I don't think there's anything we can do about it as a society, because again, that's just where we're at. We're going to have this. I think a lot more focus needs to be put there. We spend a lot of time talking with operators about, okay, when this thing doesn't know what to do, it's going to flip control back to you. Here are the scenarios where that can happen. Here's what you need to do. But it's a challenge, and that's something that we're going to face. And I think, unfortunately, we're going to see more accidents like that Air France crash where everything's fine. You just have to fly the plane. But because of someone had not spent enough time in designing that system, there was errors flying everywhere. It was alert overload, and there was panic that happened with the pilot, and that's what caused that crash. And I think we're going to see the same thing happen with these autonomous AI cars. Everything's going fine. Just drive the car. You know how to drive a car. Just drive the car. But that transition, there's errors going off, there's alerts going off, and suddenly you're in control again. And that jarring effect, I think, is very scary. So I've actually spent a lot of time thinking about that, and I'm very nervous about that. But the good news is that in the manufacturing space specifically, we've got lots of safeguards that we can put in place so that is really not as big of a concern as we're going to see in other areas. But broadly speaking, that transition point between automatic and manual is something, autonomy and manual operation is something that I am concerned about broadly. But again, I spend my whole life, my whole days thinking about AI and things. So that's, of course, something I think about. So.
It's a fascinating phenomenon, by the way. So if you talk to an engineer who designs elevators for a living or designs the airplane themselves, would you use the product you design? 100% every engineer says yes. You ask a software engineer, would you get into a plane that was running the software that you wrote to fly itself? Would you fly in that plane? I'd say it's close to 100% would say absolutely
right.
not.
Yes. Yeah. And I have a software background as well. I have a computer science degree. And yes, like for some reason, us software folks we're always concerned about all those little edge cases that could pop up. And yeah, so.
The unknown unknowns, yes. They're terrifying.
Yes.
And it's impossible to calculate for all of them. And so, just in your head, you're like, I didn't think of everything. I'm not that smart.
Right. Yeah. I think that, we're getting real philosophical now, but I think the difference there is that engineers have the benefit of physics, and so they can have multiple layers of kind of defense against those Swiss cheese problems or whatever, those black swan type of things. They have multiple layers of defense, and software tends to have only single layers of defense. And honestly, that's something that I think as software development matures as an industry, we're nowhere near what engineering in terms of number of years. Engineering goes back hundreds of years. We have, 80 years, maybe not even in software development, 50 years. So as we continue to mature as an industry around software development, I think that we need to learn those lessons and start to build in all those multiple layers of sophistication and protection and defense in depth and things like that in the cybersecurity world. Those are the types of lessons that we need to continue to learn.
Bryan, absolute pleasure, man. That was fantastic.
Thanks, Christian. Appreciate it.
And that's a wrap for this episode of Techtastic. I want to thank you personally for joining us, and we'll see you next time. Until then, keep exploring and stay curious. Thank you for listening. If you are new here and enjoyed the content, please subscribe. It really helps us out. And if you are a regular listener, thanks so much for your continued support.
Overwhelmed by tech debt? Discover Vala AI, the solution to tech challenges with the simplicity of a click. No engineering background? No problem. Vala AI enables anyone to effortlessly tackle tech issues, freeing up your time from tech headaches. Make tech debt vanish with Vala AI, where your tech solutions are just a click away.